Today we're going to take a look at a different way of measuring angles here called radians. So up until now we've just taken a look at degrees, and you guys are getting really comfortable with working in degrees here. So let's see. The first thing we're going to talk about is what is a radian. And somebody decided we had 360 degrees in a circle. But what actually happens here is if we have a circle, whoops, that's not a circle. If we take a circle, and I wonder if I can find one to actually make it a nice circle here. Let's see, shapes. I think that's, oh, here we go. So let's say we have our circle here. And in our circle, if we were to draw in our radius, what actually happens is if we take the length of our radius and we measure it on the outside, for example, if we were to stretch that, here would be 1. Put another radius, here is 2, 3, 4, 5, 6. It takes 6 radii here to make it around the circle. And what you guys know is what mathematical number, well, if it's 6 all the way around, halfway would be about 3, and there's a pretty important math number that's really close to 3, and that's pi. So 180 degrees equals pi radians. And all that radian is, it's the measure of a radius. We have radian right there, it's the measure of that radius. So when we take a look at this next screen, how do we convert back and forth? Well, 1 radian is 180 divided by pi, because we know pi equals 180 degrees. So if we divide by pi, 1 radian is 180 degrees divided by pi, and vice versa. If we want to know a degree, we know pi equals 180, so 1 degree is equal to pi over 180. So when you need to convert back and forth, what we do is we take our measurement, 215 degrees, and we're going to multiply it, kind of like how we multiply when we rationalize by the number 1. We're going to multiply this by the number 1, except I'm going to put pi radians on top, and pi radians is equal to 180 degrees. So our degrees will reduce out, so we end up with 215 pi over 180. And then you can use your calculator. Let's see if that reduces down at all, that 215 over 180. So we got 215 divided by 180. So we have 43 pi over 36. Now if we want to go the other way, we have 5 pi over 8 radians. We want it to degrees, so we want our radians gone, so I'm going to put pi radians on the bottom, 180 degrees on top, so our radians are gone, so we have 5 times 180 divided by 8. 5 times 180 divided by 8. So we have 112.5 degrees. Oops. So how can we change things quickly? Well, we know our important measurements on the triangle are our 30, our 60 and 45 degree triangles. So what is 30 degrees equal to? Well, let's see. That is, let's see, 30 times pi over 180, because we want it in radians, so our degrees are gone here. So 30 over 180, well, that's pi over 6. So 30 degrees is equal to pi over 6. What about 60 degrees times pi over 180? Well, let's see, 60 over 180, that's 1/3, so that's pi over 3. So 60 degrees equals pi over 3. And 45, well, let's see, times pi over 180. So 45, well, that goes in there, pi over 4. So 45 degrees equals pi over 4. Some of you may like to see it another way too, because there's quite a few different ways to visualize this. If in our unit circle, we know that over here is equivalent to pi. So if we look at our 45s, 1, 1, 2, 3, 4. So this is equivalent to pi over 4. And you can do similarly for 30. We'd have 30, 60, 90, 120, 150, 180. So that's 1, 2, 3, 4, 5, 6. So 30 degrees is pi over 6. And then 60 degrees, 60, 120, oops, that'd be over here. No, up here, sorry, 120, 180. So take out this one. Totally off right there. But there would be 3, so 60 is pi over 3. And we'll go over this again in a little bit. So if we needed to change this exactly to radians, if we know a couple things, if we know 30 is equal to pi over 6, 45 is equal to pi over 4, 60 is equal to pi over 3, well, 30 degrees, that's the same as 30 times 11. Well, we know 30 is pi over 6, so pi over 6 times 11. So, and you'll see it as a fraction of 11 pi over 6. If you had 120 degrees, well, that's equivalent to 2 times 60, so that's going to be 2 times pi over 3, which would be 2 pi over 3. And you can do this for any of those multiples. If we had, let's see, let's pick another one. If we had 225 degrees, we know that's a reference angle of 45s. Well, how many 45s is it? Well, it's 4, it's 5 times 45. So that would be 5 times pi over 4. So if we needed to change this to degrees, well, I see this as pi over 6, pi over 3, and I know that's 60, so this is 2 times 60, which would be 120 degrees. Let's say we had 7 pi over 4. Well, we know this is 45, so this is 7 times 45. Let's see, 45, I gotta write it this way, 5, carry the 3, 28, 29, 30, 315. So this is 315 degrees. So as long as you know those three, you're set. Pi over 6 is 30, pi over 4 is 45, pi over 3 is 60. So on our unit circle here, we're going to name all these common ones here. And so first thing we're going to look, well, this is a multiple of 30. So this would be, we know 30 degrees is pi over 6. 60 degrees, well, you could look at it as 2 30s, which is 2 pi over 6, which is really pi over 3, which we already knew. 90 is 3 30s, so 3 pi over 6, which is pi over 2. Which that one totally makes sense, because over here we know is pi, so it would make sense that that's half pi. 120, we could look at it as 2 times 60, or we could look at it as 4 times 30. So 2 times, let's do 4 times 30, so 4 pi over 6, which reduces down to 2 pi over 3, which makes sense, 260 degrees. This is 5 30s, so we have 5 pi over 6. We know this is equivalent to 6 pi over 6. So this is 7 times 30. So 7 pi over 6. Well, this is, we could do 8 times 30 or 4 times 60. I tend to do the bigger one, so this is 4 pi over 3. That would be the same thing as 8/30s, which is 8 pi over 6. This is 9/30s, so 9 times pi over 6, which reduces down to 3 pi over 2. This would be 30 times 10, so 10 pi over 6, which is 5 pi over 3, which if you notice that this is 5 times 60 degrees as well. And this is 11/30s, so we have 11 pi over 6. You guys will notice that these main ones, these are ones you'll be really familiar with as well. And it makes total sense because over here is 2 pi. So we have pi, pi over 2, and 3 pi over 2. Alright, so now we're going to look at the 45s. Well, we said there's 1, 2, 3, 4, so we know that this is pi over 4. We said that this was, well, 245, so 2 pi over 4, pi over 2, which we said that's one pretty easy one. This would be 3 pi over 4s, 4 pi over 4s, which is pi, so we got 5 pi over 4s. Here's another 45, 6 pi over 4, which we already said reduces down to 3 pi over 2, and then we have 7 pi over 4. And all the way around, that would be 8 pi over 4, which is 2 pi. So now we can start evaluating those unit circle values with radians. You can convert to degrees if you want, so 4 times 60, well that's 240. So we know that our 240 is down here, so our reference angle is 60. So negative square root of 3 over 2, negative 1/2, and 1. And what is cosine? Adjacent over hypotenuse. So negative 1/2 over 1, which is negative 1/2. So the last thing we're going to look at is arc length. Arc length is just a fraction of our circumference. And if you remember, circumference is 2 pi r. So in degrees, we just take our angle measure over 360 times 2 pi times our radius. Where in radians, it's our angle measure over 2 pi times 2 pi r, because it's just a fraction. You'll notice those are gone. So it's just our angle measure times our radius. Sector area comes from area, and area is pi r squared. So in degrees, it's just a fraction, whatever our angle measure is over 360 times pi r squared. And in radians, it would be theta over 2 pi times pi r squared, which the pi's are gone, it reduce out to 1. So it is theta over 2 times r squared. And a lot of times you'll see it written as 1/2 theta r squared. So, whoops, see if we can go back here. Whoops, sorry guys. Let's see if we can get this done quickly. Sorry, this is quite a longer podcast here, my bad. We'll try and get this. Alright, so find the area and arc length. So I'm just going to set these up. So arc length, it's that fraction of 2 pi r, theta over 360, since it's in angles, times 2 pi r. So you have 128 over 360 times 2 times pi times 12. And if we were to do area, it's our fraction of our area. So we have 128 over 360 times pi times 12 squared. All right, and the last one, I think we're going to leave this one for now. Let's see, find the area of the shaded region. I think this is supposed to be the shaded region, and I don't think we've done quite enough to solve this one, so we'll leave that for another day.